Hello once again, ladies and gentlemen, and welcome to our virtual classroom. Today we're going to be going over inequalities again. However, this time we're going to be going over actually how to solve inequalities. So this is our lesson 15-2 in our textbook, and this is solving inequalities, numbers 1 through 14. This is going to be a pretty short video because, ladies and gentlemen, when solving inequalities, our goal is the exact same goal as it was when solving equations. Our goal when solving inequalities, simply put, is to isolate the variable. And what does it mean to isolate the variable? That means we want the variable to be all by itself. Similarly to how it was with an equation where we had something like 3x is equal to 12, or something like 3 plus x is equal to 10. In both of those scenarios, we can see that we want the variable to be all by itself. We want to get to the point where it's just x is equal to something, right? And so in this first scenario, the x is not isolated because we're multiplying by 3. All right, so the way that I isolated the variable is I would do the opposite operation. I would do I would do the opposite operation of multiplication, which is division, so that the variable would be isolated. However, whatever I did to one side, I would do to the other, right? So 12 divided by 3 would be 4. So in this first scenario, x would have to equal 4. Now over here in the bottom one, similarly, we want to isolate the variable. And it is not isolated because this time we're adding 3. So the opposite of adding 3 was to subtract 3. And whatever I did to one side, I did to the other. And now the variable would be isolated, and 10 minus 3 is 7. And so that is how we would solve equations. Well, when solving inequalities, ladies and gentlemen, again, it is the exact same process. And to show you that, let's go to this example right here. Here we're given x plus 21 is less than or equal to 46. Now, please do not let this symbol confuse you. All right, we're going to solve it as if that was an equal sign. Okay, so it doesn't matter if it says less than or equal to, greater than or equal to, or just less than or greater than. We're going to treat this still as if it was a scale. And again, our goal is to isolate the variable, get the variable by itself. We're going to use the opposite operation of whatever's happening to the variable. And whatever we do to one side, we must do to the other. Okay, so let me solve this down here, actually. All right, so we have x plus 21 is less than or equal to 46. So here's my variable. It is not isolated because I'm adding 21. How do I get rid of plus 21? I do the opposite operation, which is to subtract 21. Good. And so that cancels the variable. I mean, the number, the variable is now by itself. However, whatever I do to one side, I must do to the other so that it remains balanced. Okay, so let's go ahead and subtract 21 from 46. 6 minus 1 is 5. 4 minus 2 is 2. So ladies and gentlemen, x can be any number as long as that number is less than or equal to 25. That is my solution. Not 25. No, my solution is any number. X can be any number that is less than 25 or exactly 25. So that's what I mean by what does this mean? Unlike the only real difference when solving inequalities and equations is that with an equation, for example, if this was an equal sign, this would just say x is 25. 25 is the number that has to be x so that this would be a true statement. But here, notice how any number that I put that is either less than 25 or equal to 25 will make this a true statement. For example, let's pick a number that is less than 25. Let's pick the number 2. All right, so let's see if 2 plus 21 is less than or equal to 46. Well, 2 plus 21 is equal to 23. Ladies and gentlemen, is 23 less than 46? Yes. Less than or equal to 46? Yes, it is definitely not equal to, but it is less than. So that works. Even if I use the highest possible number, 25. So 25 plus 21, that would give me 46. Ladies and gentlemen, is 46 less than or equal to 46? Yes. So again, any number that is less than 46 or equal to less than 25 or equal to 25 will work. Let's try one more together. And I'll have a few more here. Again, let's isolate the variable. So we have 2.3 plus x is equal to 7.7. This should be an inequality. So let me put an inequality symbol right here. Okay, so let's just say that 2.3 plus x is less than 7.7. All right, well, the opposite of adding 2.3 is to subtract 2.3. Good. So now x is isolated, but whatever I do to one side, we keep the same symbol, guys. Make sure you keep the same symbol. So this is going to be minus 2.3. We do to the other. So 7 minus 3 is 4. Since we're subtracting, we just bring down the decimal. 7 minus 2 is 5. Ladies and gentlemen, x has to be less than 5.4. It is literally the exact same process. Notice this one. In this one, we are multiplying. So the opposite of multiplication is division. So instead of multiplying by 3, I'm going to divide by 3 so that x is now isolated. We bring down the same symbol. Okay, so we have less than, and this is going to be 8. So 8, no, my bad, I'm sorry. We have to do the same thing to the other side, right? So 8 divided by 3. So I'm going to divide 8 into 3 parts. 3 goes into 8 twice. That's going to be 6. Bring down the 2. Bring down the decimal. Bring down the 0. 3 goes up to 20. 6 times. That's going to be 18. Remainder 2. Bring down the 0. It's going to go on forever. So it's going to be 2.66666, etc. Regardless, do you get the point? Again, ladies and gentlemen, when solving inequalities, it is the exact same process that we were doing before. And so with that in mind, I hope that this was helpful to you, and I will see you next time.